Alright, so this video will be talking about volume of pyramids and volumes of cones. So let's first start with our pyramids. When we did prisms and cylinders, it was the area of the base times the height. So if I had, imagine that I had a prism that had the same base as this pyramid, you can see that the prism would hold a lot more than the pyramid. And in fact, a prism will hold 3 times as much. So the formula for the area, for the volume of a pyramid is going to be 1/3 the area of the base times the height of the pyramid. So B is the area of the base, and H is the height of the pyramid. And it's important to remember that the height has to be perpendicular to the base. And it's the distance that goes from the vertex to the base. Because the vertex, of course, is the highest point. So this segment right here would represent the height of the pyramid. All right, so let's take a look at an example. We're going to find the volume of a pyramid with a regular base. Now, notice that this is oblique. It turns out with volume, it doesn't matter if it's right or oblique. The important thing is that the height has to be perpendicular, but the actual pyramid does not have to be a right pyramid. So we're going to find the volume, and it has a regular base. So if I count the sides, I can see that's a hexagon. And the side lengths are 4. Central angle is going to be 60 degrees. When I cut it in half, that becomes a 30, 60, 90. Half my side is 2, and so my apothem is 2√3. So the area of the base is going to be 6 triangles times 1/2 base times height. And so that comes out to 24√3. And then I can see that the height they gave me as 10 inches. And so the volume, I just plug that all in. The volume is 1/3 the area of the base, which was 24√3, times the height of the pyramid, which is 10. That comes out to 80√3. That would be the exact volume. If it asks for the approximate or asks for decimals, you can just put that in your calculator. This comes out to 138.56 cubic inches. Again, volume is in cubic units. When we're looking at cones, it's also 1/3 the area of the base times the height. And in this case, the base is a circle, so it's pi r squared, and then times the height. Now notice I actually want the height, again, that's perpendicular from the vertex to the base. I am not looking for the slant height. Okay? Don't care about the slant height for volume. So let's just make a note here, though. Again, the height is perpendicular to the base. All right. So let's take a look at some examples. We're going to find the volume of the cone for a right cone and an oblique cone, and it makes no difference. We're going to use the same formula for both of them. So the volume is 1/3 pi r squared h. So in this particular case, 1/3 pi the radius is 9.5, so we square that, and then the height is 16.8. So if we plug that all into our calculator, you should get approximately 1,587.8 millimeters squared. I mean cubed. Sorry. Okay. All right. The oblique cone, you're going to do the same thing. You're going to use the volume equals 1/3 pi r squared h. So why don't you try and figure that one out yourselves. Pause the video now. All right, so when you did that, hopefully you used 4.5 for the radius and squared it, 12 for the height, and then 1/3 pi, multiply it all together. You should have gotten 254.5 cubic feet. Let's take a look at another example. Here, I want to find the volume, but they have not given me the radius. Instead, they have given me an angle. So whenever I have an angle and a side, I can use one of my trig ratios. So I have the opposite here and the adjacent. So I'm going to use tangent. So the tangent of 62 is going to equal the opposite, 12, over the adjacent, r. And so using algebra, we know that r then would equal 12 divided by the tangent of 62. And so if you put that in your calculator, you should get approximately 6.38. And of course, you can leave it in your calculator so that you get a more precise answer. So we plug that in then to the volume, 1/3 pi, the 6.38 squared, and then times the height of 12. And so we get approximately 511.6 cubic meters. All right, so now we'll take a look at some composite solids. With composite solids, you just add the volume of the two parts, or if something is cut out of it, you subtract it. In this particular case, we are going to have the volume of the cone plus the volume of the cylinder. And so the volume of the cone is 1/3 pi r squared h, h being the height of the cone, and the volume of the cylinder, pi r squared h, in this case h being the height of the cylinder. All right, so the radius is 3, and the height of the cone is 3. For the cylinder, the radius is 3, but the height is 7. So if we multiply that together, we get 9 pi plus 63 pi. That adds up to 72 pi, so your exact volume would be 72 pi. If you put that in your calculator, it comes out to 226.2 cubic centimeters. This next example, we're going to find the volume, but it turns out that the cone is being cut out of the cube. So we're going to have the volume of the cube minus the volume of the cone. So the volume of the cube is just going to be the side cubed, and it's going to be minus 1/3 pi r squared h. All right, so all the sides are 5.1, so I'm going to take 5.1 and I'm going to cube that. And from that, I will subtract the product of 1/3 pi, or 5.1 over 2 is my radius, because it's only half the side, squared, and then the height of 5.1. Because yeah, when you're figuring out your radius over here, it's just half the side. So it's 5.1 divided by 2. All right, so if we put all of that into our calculator, 5.1 squared or cubed, I get 132.651. And from that, I'm going to subtract what I get for this. So let's see here. $34.728. And so when we subtract that and just make it to the nearest tenth, we get that the volume is 97.9 cubic meters. And that concludes this video. Thank you.